Okay, hi everyone, welcome back to this video on Server 2012. Understanding option assignment. You can control with DHCP options are doled out to clients in 5 ways. Predefined options are templates that are available in the server scope or client options dialog box. Server options are assigned to all scopes and clients of a particular server. That means if there's some setting you want all clients on a DHCP server to have, no matter what scope they're in, this is where you assign specific options. Those that are set at the class, scope, or client level will override server level options. That gives you an escape valve. It's a better idea, though, to be careful about which options you assign if your server manages multiple scopes. Scope options. If you want a particular option value assigned only to those clients in a certain subnet, you should assign it as a scope option. For example, it's common to specify different routers for different physical subnets. If you have two scopes corresponding to different subnets, each scope would probably have a separate value for the router option. Class options. You can assign different options to clients of different types. That is class options. For example, Windows 2000, XP, Vista, Windows 7, Windows 8, Server 2003, Server 2003 R2, Server 2008, Server 2008 R2, and Server 2012 and Server 2012 R2 machines recognize a number of DHCP options. That's Windows 98, Windows NT, and Mac OS machines ignore, and vice versa. By defining a Windows 2000 or newer class using the ipconfig /classid ID command you saw earlier, you can assign those options only to machines that report themselves as being in that class. Client options. If a client is using DHCP reservations, you can assign certain options to that specific client. You can attach client options to a particular reservation. Client options override scope, server, and class options. The only way to override a client option is to configure the client manually. The DHCP server manages client options. Assigning options. You can use the DHCP snap-in to assign options at the scope, server, reserved address, or class level. The mechanism you use to assign these options is the same for each. The only difference is where you set the options. When you create an option assignment, remember that it applies to all of the clients in the server or the scope. From that point forward, option assignments aren't retroactive and they don't migrate from one scope to another. Creating and assigning a new option. To create a new option and to have it assigned, follow these steps. 1. Select the scope or server where you want the option assigned. 2. Select the corresponding options node and choose action configuration options. To set options for a reserved client, right-click its entry in the reservations node and select configure options. Then you will see the scope options dialog box, which lists all of the options that you might want to configure. 3. To select an individual option, check the box next to it and then use the controls in the data entry control group to enter the value you want associated with the option. 4. Continue to add options until you specified all of the ones you want attached to the server or scope, then click OK. Configuring the DHCP server for classes. You saw how to assign classes to individual machines earlier in this chapter. Now you will learn how to configure the DHCP server to recognize your customized classes and configure options for them. In exercise 211, you will create a new user class and configure options for the new class. Before you begin, make sure that the computers you want to use in the class have been configured with the ipconfig set class ID command as described in the section ipconfig lease options early in the chapter. Configuring user class options. Open the DHCP snapping by selecting Administrative Tools, DHCP. Right-click the IPv4 item and select Define User Classes. 3. Click the Add button in the DHCP User Classes dialog box. 4. In the New Class dialog box, enter a descriptive name for the class in the Display Name field. Enter the class ID in the ID field. Typically, you will enter the class ID in the ASCII portion of the ID field. When you finish, click OK. 5. The new class appears in the DHCP User Classes dialog box. Click the Close button to return to the DHCP snap-in. 6. Right-click the Scope Options node and select Configure Options. 4. Click the Advanced tab. Select the class you defined in Step 4 from the User Class pop-up menu. 8. Configure the options you want to set for the class. Click OK. When you have finished, notice that the options you configured appear in the right pane of the DHCP window, activating and deactivating scopes. When you've completed the steps in exercise 2.5 and you're ready to unleash your new scope so that it can be used to make client assignments, the final required step is activating the scope. When you activate a scope, you're just telling the server that it's okay to start handing out addresses from that scope's address pool. As soon as you activate a scope address from the pool, it may be assigned to clients. Of course, this is a necessary precondition to getting any use out of your scope. If you later want to stop using the scope, you can, but be aware that it's a permanent change. When you deactivate a scope, DHCP tells all clients registered with the scope that they need to release their leases immediately and renew them somewhere else, creating a superscope for IPv4. A superscope allows the DHCP server to provide multiple logical subnet addresses to DHCP clients on a single physical network. You create superscopes with the new superscope command, which triggers the new superscope wizard. Creating a superscope. Open the DHCP snap-in by selecting Administrative Tools, DHCP 2. Follow the instructions in exercise 2.10 to create two scopes, one for 192.168.0.2 through 192.168.0.127 and one for 192.168.1.2 through 192.168.1.127. Right-click IPv4 and choose the new Superscope command. The new Superscope wizard appears. Click the next button on the Superscope new page. Name your Superscope and click the next button. 5. The Select Scope page appears, listing all scopes on the current server. Select the two scopes you created in step 2 and then click the next button. 6. The wizard's summary page appears. Click the Finish button to create your scope. 7. Verify that your new scope appears in the DHCP snap-in. Deleting a superscope. You can delete a superscope by right-clicking it, and choose the delete command. A superscope is just an administrative convenience, so you can safely delete one at any time if it doesn't affect the real scopes that make up the superscope. Adding a scope to a superscope. To add a scope to an existing superscope, find a scope you want to add, right-click it, choose Action, Add to Superscope. A dialog box appears listing all of the superscopes known to this server. Pick the one to which you want the current scope appended and click the OK button. Removing a scope from a superscope. To remove a scope from a superscope, open the superscope, right-click the target scope. The pop-up menu provides a remove from superscope command that will do the deed, activating and deactivating Superscopes. Just as with regular scopes, you can activate and deactivate Superscopes. The same restrictions and guidelines apply. You must activate a Superscope before it can be used, and you must not deactivate it until you want all of your clients to lose their existing leases and be forced to request new ones. To activate or deactivate a Superscope, right-click the Superscope name and select Activate or Deactivate, respectively, from the pop-up menu. Creating IPv4 multicast scopes. Multicasting occurs when one machine communicates to a network of subscribed computers rather than specifically addressing each computer on the destination network. It's much more efficient to multicast a video or audio stream to multiple destinations than it is to unicast it to the same number of clients, and the increased demand for multicast-friendly network hardware has resulted in some head-scratching about how to automate the multicast configuration. In the following sections, you will learn about MADCAP, the protocol that controls multicasting, and how to build and configure a multicast scope, understanding the multicast address dynamic client. Allocation Protocol. DHCP is usually used to assign IP configuration information for unicast or one-to-one network communication. With multicast, there's a separate type of address space assigned from 224.0.0.0 through 239.255.255.255. Addresses in this space are known as Class D addresses or simply multicast addresses. Clients can participate in a multicast just by knowing or using the multicast address for the content they want to receive. However, multicast clients also need to have an ordinary IP address. How do clients know what to use? Ordinary DHCP won't help because it's designed to assign IP addresses and option information to one client at a time. Realizing this, the Internet Engineering Task Force, IETF, defined a new protocol, Multicast Address Dynamic Control Allocation Protocol, MADCAP. MADCAP provides an analog to DHC, but for multicast use. An MADCAP server issues leases for multicast addresses only. MADCAP clients can request a multicast lease when they want to participate in a multicast. DHCP and MADCAP have some important differences. First, you have to realize that the two are totally separate. A single server can be a DHCP server, MADCAP server, or both. No implied or actual relation exists between the two. Likewise, clients that use DHCP and or MADCAP at the same time, the only requirement is that every MADCAP client has to get a unicast address from somewhere. Building multicast scopes. Most of the steps you go through when creating a multicast scope are identical to those required for an ordinary unicast scope. Creating a new multicast scope. Open the DHCP snap-in by selecting Administrative Tools, DHCP. Right-click IPv4 and choose New Multicast Scope. The New Multicast Scope wizard appears. Click the next button on the welcome page. In the Multicast Scope new page, name your multicast scope. Click the next button. The IP address range appears. Enter the start IP address of 224.0.0.0 and an end IP address of 224.255.0.0. Adjust the TTL to 1 and make sure that no multicast packets escape your local network segment. Click the next button when you're finished. The Add Exclusion page appears. Click its next button. The least duration page appears. Since multicast addresses are used for video and audio, you would ordinarily leave multicast scope assignments in place somewhat longer than you would with a regular unicast scope. So the default length lease is 30 days instead of 8 days for a unicast scope. Click the next button. The wizard asks if you want to receive the new scope. Click the no radio button and then the next button. The wizard's summary page appears. Click the finish button to create your scope. Verify that your new multicast scope appears in the DHCP snap-in. Settings. Setting multicast scope properties. Once you create a multicast scope, you can adjust its properties by right-clicking the scope name and selecting properties. The multicast scope properties dialog box has two tabs. The general tab allows you to change the scope's name, its start and its end, its time to live TTL value, its lease duration, and its description. In essence, all of the settings you provided when you created it in the first place. The lifetime tab allows you to limit how long your multicast scope will be active. By default. A newly created multicast scope will live forever. But if you're creating a scope to provide MAD/CAP assignments or a single event or set of limited duration, you can specify an expiration time for the scope. When that time is reached, the scope disappears from the server, but not before making all of the clients give up their multicast address leases. This is a nice way to make sure that the lease client cleans up after itself when you're finished with it. So we'll just have a look here. Figure 241, general tab for the multicast scope properties dialog box. Figure 242, lifetime tab of the multicast scope properties dialog box. Integrating dynamic DNS and IPv4 DHCP. DHCP integration with dynamic DNS is a simple concept but powerful in action. By setting up this integration, you can pass addresses to DHCP clients while still maintaining the integrity of your DNS services. The DNS server can be updated in two ways. One way is for the DHCP client to tell the DNS server its address. Another way is for the DHCP server to tell the DNS server when it registers a new client. Neither of these updates will take place, however, unless you configure the DNS server to use dynamic DNS. You can make this change in two ways. If you change it at the scope level, it will apply only to the scope. If you change it at the server level, it will apply to all scopes and Superscopes served by the server. Which of these options you choose depends on how widely you want to support dynamic DNS. Most of the sites I visit have enabled DNS updates at the server level. To update the settings at either the server or scope level, you need to open the scope or server properties by right-clicking the appropriate object and choosing properties. The DNS tab of the properties dialog box includes the following options. Enable DNS dynamic updates according to the settings below. This checkbox controls whether this DHCP server will attempt to register lease information with a DNS server. It must be checked to enable dynamic DNS. Dynamically update DNS A and PTR records only if requested by the DHCP clients. This radio button tells the DHCP server to register the update only if the DHCP client asks for DNS delegation. When this button is active, DHCP clients that aren't hip to DDNS won't have their DNS records updated. However, Windows 2000, XP Vista, Windows 7, Windows 8, Server 2003, 2003 R2, Server 2008, Server 2008 R2, Server 2012, 2012 R2, DHCP clients are smart enough to ask for the updates. Always dynamically update DNS-A and pointer records. This radio button forces the DHCP server to register any client to which it issues a lease. This setting may add DNS registrations for DHCP-enabled devices that don't really need them, such as print servers. However, it allows other clients such as Mac OS, Windows NT, and Linux machines to have their DNS information automatically updated. Discard A and PTR records when the lease is deleted. This checkbox has a long name, but a simple function. When a DHCP lease expires, what should happen to the DNS registration? Obviously, it would be nice if the DNS record associated with a lease vanished when the lease expired. When this checkbox is checked, as it is by default, that's exactly what happens. If you uncheck this box, your DNS will contain entries that for expired leases that are no longer valid. When a particular IP address is reissued on a new lease, the DNS will be updated, but in between leases, you'll have incorrect data in your DNS, something that's always best to avoid. Dynamically update DNS and PTR records for DHCP clients that do not request updates. This checkbox lets you handle older clients graciously by making the updates using a separate mechanism, enabling DHCP-DNS integration. Open the DHCP snap-in by selecting Administrative Tools DHCP. Right-click the IPv4 item and select Properties. The Server Properties dialog box appears. Click the DNS tab. Verify that the checkbox labeled Enable DNS Dynamic Updates according to the setting below is checked, and verify that the radio button labeled Dynamically Update DNS-A and PTR records only if requested by the DHCP client is selected. Verify that the checkbox labeled A and PTR records when lease is deleted is checked. If not, then check it. Click the OK button to apply your changes and close the Server Properties dialog box. Using multiple DHCP servers, DHCP can become a single point of failure within a network if only one DHCP server. Sorry, if there's only one DHCP server. If that server becomes unavailable, clients will not be able to obtain new leases or renew existing leases. For this reason, it is recommended that you have more than one DHCP server on the network. However, more than one DHCP server can create problems if they are both configured to use the same scope or set of addresses. Microsoft recommends the 80/20 rule for redundancy of DHCP services in a network. Implementing the 80/20 rule calls for one DHCP server to make approximately 80% of the addresses for a given subnet available through DHCP, while another server makes the remaining 20% of the addresses available. For example, with a /24 network of 254 addresses, say 192.168.1.1 to 192.168.1.254, you might have server 1 offer 192.168.1.10 to 192.168.1.210, while server 2 offers 192.168.1.211 to 192.168.254. DHCP load sharing. Load sharing is the normal default way to use multiple DHCP servers. Both servers cover the same subnets simultaneously, and both servers assign IP addresses and options to clients on the assigned subnets. The client requests are load balanced and shared between the two servers. This is a good option for a company that has multiple DHCP servers in the same physical location. The DHCP servers are set up in a failover relationship at the same site, and both servers respond to all DHCP client requests from the subnets to which they are associated. The DHCP server administrator can set the load distribution ratio between the multiple DHCP servers. DHCP Hot Standby. When thinking of a DHCP Hot Standby setup, think of the old server failover cluster. You have two servers where one server does all of the work and the other server is a standby server in the event that the first server crashes or goes down. In a DHCP hot standby situation, the two DHCP servers operate in a failover relationship where one server acts as an active server and is responsible for releasing IP addresses to all clients in a scope or subnet. The secondary DHCP server assumes a standby role and it is ready to go in the event that the primary DHCP server becomes unavailable. If the primary server becomes unavailable, the secondary DHCP server is given the role of the primary DHCP server and takes over all of the responsibilities of the primary DHCP server. This failover situation is best suited to DHCP deployments where a company has DHCP servers in multiple locations. Working with DHCP database files, DHCP uses a set of database files to maintain its knowledge of scopes, superscopes, and client leases. These files, which live in the system root system32/DHCP folder, are always open when the DHCP service is running. DHCP servers use joint engine technology, JET databases to maintain their records. Summary. DNS was designed to be a robust, scalable, and high-performance system for resolving friendly names to TCP IP host addresses. This chapter presented an overview of the basics of DNS and how DNS names are generated. When we then looked at the many new features available in the Microsoft Windows Server 2012 R2 version of DNS, and we focused on how to install, configure, and manage the necessary services. Microsoft's DNS is based on a widely accepted set of industry standards. Because of this, Microsoft's DNS can work with both Windows and non-Windows based networks. This chapter also covers the DHCP lease process as it relates to TCP IP configuration information clients. The following stages were covered: IP discovery, IP lease offer, IP lease selection, and IP lease acknowledgement. You learned how to install and configure the DHCP server on a Windows Server 2012 R2 and how to create and manage DHCP scopes and scope options. I also discussed the authorization of DHCP servers within Active Directory and scopes for IPv4 and IPv6 and showed how to create them. Finally, I covered Superscopes as well as managing client leases with options therein. So I won't leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.